Okay, this is Advanced Math, Unit 1, which is Fundamentals, and this is lesson number 3. We're going to look at rational expressions. Now, rational just means it's fraction. Expression means you're not going to solve it. It's not an equation. We're just going to be simplifying it. So before we go into this review, let's even review further back. Let's just think about fractions that are not algebraic. If you needed to reduce 6 over 8, what you used to do is you would say what number will go into both of them, and both of them could be divided by 2, so you would simplify that down to 3/4. Well, what if we looked at it in a different way? What if we factored each term? You see the common factor here cancels out. It divides out to 1 is what it does. I don't just want to say cancels out because it divides into 1, and 1 times any number is just that number. So we wound up with 3/4. You can do this algebraically. Let's say I've got 3x over 6x. Well, 3x factors into 3 times x. 6x would factor into 2 times 3 times x. Your 3's divide out, your x's divide out, and what you have left is 1/2. That's more along the lines of the system that we're going to use to factor these rational expressions. Now, one thing to remember is factors can cancel, terms cannot. Okay? Factors can cancel, but terms cannot. Okay, let's just consider these two options. Here I've got 3xy. What are my factors? Well, this is actually 3 times x times y and 2 times x times y. So the x's would divide out, the y's would divide out. You get 3/2. Now look at this one. 3x plus y and 2x plus y. These are not factors anymore, they're terms. So you cannot cancel. Y is not multiplied times 3x, it's added. So you can't cancel that. What can you cancel here? Absolutely nothing. This is already in simplest form. So I want you to look at the difference between factors and terms. Factors can cancel, terms cannot. Okay, so this is a rational expression, and we want to simplify it. Can you simplify this? Well, you can't cancel out anything as it is. So when you simplify a rational expression, your first step is to factor, if possible. All that stuff we learned in lesson 2 about factoring polynomials, well, that's fixing to be just the first step in all of these problems, okay? So let's look at this binomial. What was your first step when you were factoring a polynomial? Look for a greatest common factor. What's the greatest common factor between 2x and 2y? Well, a 2 is. So we would factor this into x plus y. Alright, look down here. What's your greatest common factor between 3x and 3y? 3. And when you factor that out, you get x plus y. Now, x plus y is a factor. So if it matches, it can cancel. And this would simplify into 2/3. Alright, now let's look at this last reminder before we get into the real rational expressions. If you have addition, addition is commutative, so yes, these are the same thing. X plus y, you can revert these to x plus y, cancels out, you got 1. Alright, now, this is a difference. Subtraction is not commutative. 5 minus 3 is not the same thing as 3 minus 5. So, these don't match, and we learned a process back in Algebra 2 or earlier advanced math where you could convert this. And what you did is you said you can do anything you want to a fraction as long as you do it to the numerator and the denominator. So what we did is we multiplied by -1 over -1. Is that ringing a bell? Alright, so let's look. We're not going to use our top -1. We're just going to leave it there. But we are going to use the one on the bottom. We're going to distribute it into this binomial. When I distribute it into here, what do I get? I get negative y plus x. It just changed everything, right? So I'm going to leave the negative 1 up here, leaving the numerator just like it is. Now, since this is a plus sign, I can reverse it. Now the minus sign belongs to the y, it's going to stay. So now you have something you can cancel out, and that simplifies to negative 1. So like I said, this is not technically a problem. This is a technique that you will use when you find a problem that has a difference, but the numbers are in the opposite order. So you need to be looking for that, and you'll be practicing this a lot. So let's get into some problems now. The first section says simplify. Now that means to factor and reduce. You cannot simplify a rational expression until you have factored it. That's kind of like a definition that needs to come to mind. You need to memorize the fact that simplify rational expressions means factor then reduce. So all those factoring techniques that we learned in lesson 2, the previous lesson, well, that's fixing to be just the first step. So I am going to go through the factoring kind of rapidly. If you're having trouble with it, you need to practice it more, number 1. Go back and watch lesson 2, or come ask me for some more practice. All right. To factor the top part, 64k to the third minus 1, that is a difference of 2 cubes. So I went ahead and wrote the formula over here. I'm going to need the cube root of this minus the cube root of that. Then I'm going to take this squared, which is 16k squared, plus 4 times 1, which is 4k, plus this squared, which is 1. All right. Then I need to see if this will factor anymore. It would be an AC method. So I would do 16 times 1, which would be 16. Is there a pair of numbers, 2 and 8? Is there a pair of numbers that will multiply to give me 16 but add up to give me 4? No, there's not. So I can't factor this. This is lowest terms. Alright, now down here I have another trinomial. I do have a coefficient in front of my quadratic term, so I am going to use that AC method. A times C, 4 times 3 is 12. And I'm looking for a pair of numbers that multiply to give me 12, but add up to give me 13. 1 and 12. So I'm going to rewrite this as 4k to the second minus 1k minus 12k plus 3. Remember, with the AC method, you take a trinomial and you convert it to a 4-term polynomial by splitting this middle term, and then you factor by grouping. So I'm going to group and group. All right, my greatest common factor here is k, so that will leave me with 4k minus 1. All right, I've got a minus sign. The greatest common factor between 12k and 3 is 3, so that's going to factor out and give me 4k. Now remember, this is a negative, so it's going to change that. All right, now when I come up here to put my final version, this is going to be my first set of parentheses, and these two will be my second. All right. Now, sets of parentheses are factors, so if the whole set matches, you can cancel it. And then your final answer is just going to be this trinomial over this binomial. So that would be 16k squared plus 4k plus 1 over k minus 3. Okay, example number 2, 12n to the second minus 48n over 288n squared minus 18n to the fourth. Since it says simplify, it automatically tells me that I've got a factor. All right, let's look at the numerator first. This is a binomial, so I'm looking for a greatest common factor first. What will go into 12 and 48? Obviously 12. Now I also have an n to the second and an n, so I can take the smallest exponent. All right, so now when I undistribute that, well, what if I wanted to multiply 12n times something to get this back? That would be n. It's going to be a minus sign. What would you multiply 12n by to get 48n? Just 4. Okay? So I look at my binomial here. It can't be factored, so I'm good to go there. Now let's come down here. I have another binomial. So I need to find the greatest common factor. Now what is the greatest common factor between 288 and 18? And I want to take this opportunity to remind you of a very good function on your calculator, and that is finding least common divisors, which is what we have here. So if you look on your calculator, if you hit the math button, it comes up with those options. Option number 3, the GCD, will give you a menu like this. Now, the problem is it's only going to find the GCD for 2 numbers. So if you have 3 or more, it's not going to work. And now all you have to do is type in 288. Now, you do need the comma down here. So that's your second period. And then 18. All right, now when you hit enter, you see that 18 is actually the largest number that will go into both of those numbers. So while there are other ways to find greatest common divisors, as the calculator calls it, that was a pretty quick way. So that tells us that 18 will be our greatest common factor. We can take the lowest exponent of n that we have, which is n squared. All right, if I want to multiply 18 times 18 into the second times something to get 288, what will that be? You can use a calculator and it's going to tell you 16. All right, minus 18n squared times what would give you 18 into the fourth? Well, we're going to need n to the second. Now, when I look at this binomial, I see that I still have a difference of 2 squares. So let me come over here. I'm not going to change anything in my numerator. I'm not going to change anything with my first factor, but I am going to factor this as a difference of 2 squares so that it is 4 minus n, 4 plus n. Okay? Now, let's reduce. 12 and 18, what can I reduce that by? 6. 6 will go into both of those. 12 divided by 6 would leave me 2, and 18 divided by 6 would leave me 3. Now when you reduce the n over the n, I've got n on top, n squared on the bottom, so that leaves me an n on the bottom. So let me come down here and clean this up. I have 2 times n minus 4 left in my numerator, and I have 3n times 4 minus n times 4 plus n. Now when we were reviewing the basics, if you'll remember, I told you if you run into a case where you have the same numbers with a minus sign in between them, but they're in a different order, there is a technique you can use to convert those so that they'll match and you can cancel them. Do you remember what that was? You multiply both top and bottom by -1. Okay? Now you're only going to use one of these, whichever one you want to. I usually use the one in the denominator. So up here on my numerator for right now, I'm going to keep, let me start over here. I'm going to keep 2 like it is. I'm going to keep n minus 4 like it is. And now I have -1. Well, down here, I'm actually going to multiply the -1 times this. So when I multiply -1 times that, I get -4 plus n, which I can turn around to be n minus 4. So now what do I have left on my denominator here? I've got 3 times n, I've got n minus 4, and I've got 4 plus n. So now these two things cancel out. Alright, now this -1, I can go ahead and multiply it times the -2. So that's going to leave me a -2 on the top and 3n times 4 plus n on the bottom. Now, should you distribute that back in there? No. Because if you need to do anything else, your first step would be to factor it. So we're not going to be doing any more distributing. Now there will come a case later on when you have to distribute so that you can refactor, but as for now, if you're down to lowest terms, you're good to go. Okay, so let's look at example 3. Now it says multiply, but you know that when you multiply two fractions together, what you actually do is you just multiply all the way across the top and you multiply all the way across the bottom. So technically, I just have factors here. Now none of them match, so I can't cancel at this point. I'm going to have to factor before I can simplify. Let's look at this first trinomial. So you see now I have 4 factoring problems before I can simplify. This trinomial has no greatest common factor. So how do you factor a trinomial without a coefficient in front of the first terms? Well, it's going to be 2 binomials. Whatever this is going to be the square root of it on both. Now your signs. Since it's a minus sign, you're going to have one of each. Now we need to figure out what 2 numbers go here. These 2 numbers have to multiply to give us negative 24, and it's going to be negative because you got one of each sign. They have to add up to give me negative 10. So let's just think about it. Negative 1, positive 24, positive 1, negative 24, negative 2, positive 12, positive 2, negative 12, and there's our winner. Positive 2 plus negative 12 will give me negative 10. So I'm going to put the 12 with the minus and the 2 here. Okay. Now let's factor this one. What's the greatest common factor? This is a binomial. We're going to look for a greatest common factor. 5x will go into both of these. Now 5x is actually 2 factors, and you could separate them if you need to, if you want to, but we'll just leave them together for right now. Now when I divide 5x from x squared, what do you have left? X to the first. When you divide this out, what do you get? Minus 4. So now let's do our denominator. We have a binomial here. Greatest common factor is going to be x to the second power. And when you divide x to the second out of here, what do you have left? X plus 2. Okay. Move on to here. I have a trinomial. I do not have a greatest common factor. I also do not have a coefficient in front of the first term. So it is going to factor into 2 binomials. The first term in each binomial will be the square root of this number. The signs, since it's a plus sign, they'll be the same, and they're going to be whatever this is. So minus and minus. Now, I need a pair of numbers that will multiply to give me 48 and add up to give me 16. So you got 1 times 48, 2 times 24, 3 times 16, 4 times 12, and here's our winner. Negative 4 plus negative 12 will give us negative 16. Negative 4 times negative 12 gives us positive 48. So we can put minus 4, minus 12. Okay? So let's see what we can cancel out right off the bat here. X plus 2's match. X minus 12's match. Your X minus 4's match. So what do you have left at this point? Well, you have 5x over x squared. Can you cancel anything there? Yes. Remember I told you these are actually factors, so you can cancel them. Here you've got an x to the first and an x to the second, so that's going to leave you 5 over x. Final answer. This is example 4, and we have these 2 rational expressions multiplied together. We need to simplify. So just like the last one, when you multiply, what you're actually going to do is everything on the top is multiplied, everything on the bottom. So we have these 4 expressions that we need to factor. Let's take them one at a time. I'm going to do my scratch work over here and then put the simplified form over here, and then I'll have to erase because I'm not going to have enough scratch room for this. Alright, if you take 5p squared plus 29p minus 6 and we want to factor it, there is no greatest common factor. We have a trinomial. We do have a coefficient in front of the first term, so we have to use the AC method. So when I multiply a times c, I get negative 30. Now I'm looking for a pair of numbers that multiply to give me negative 30, but add up to give me positive 29. All right, that's going to be 30 times negative 1. Now with the AC method, what you're going to do for your next step is you're just going to rewrite that trinomial using these two numbers instead of the middle term. See, all I did, instead of 29p, I put 30p minus 1p. Now we are ready to factor by grouping. So the greatest common factor here is 5p. And when I factor that out, I'll get p plus 6. Over here, my greatest common factor is only 1. If you're trying to factor by grouping and you have a pair that does not have anything larger than 1, then pull out the 1. Now when you pull out a negative 1, it's going to change that to p plus 6. And you can see I have the matching pair. So my first set of factors is p plus 6. And what do you have left over? 5p minus 1. Alright, that is this first trinomial factored. That's kind of intense for just a part of a problem, isn't it? Alright, now let's look here. We have a binomial. Does it have a greatest common factor? It does. 3p will go into both of these. So let's factor that out. I'll get p minus 5. And that's all you can do to that. Now let's grab this trinomial. Alright, same thing. There is no greatest common factor. I have a coefficient in front of the first term. I have to use the AC method. 5 times 5 is 25. I need a pair of numbers that will multiply to give me 25, but add up to give me 26. Well, how about 1 and 25? Now, since this is positive, this is negative, they're both negative. So we are going to rewrite this as 5p to the second minus 1p minus 25p plus 5. I just took the middle term and I broke it up into 2 so that I have a 4-term polynomial, and that way I can factor by grouping. Now the greatest common factor here is a p, so I'm going to have 5p minus 1. My greatest common factor here is 5, and it's negative, so it's going to change that sign. So now I have 5p instead of plus, minus 1. My factors match, so that becomes one factor. And then these two numbers become the other factor. So now I have 5p minus 1 and p minus 5. Alright, my last one. It is a binomial. There is no greatest common factor, but it is a difference of 2 squares. So that's going to factor into 6 plus p, 6 minus p. Okay, let's cancel at will. P plus 6 and 6 plus p is the same thing, so we can cancel that out. 5p minus 1 cancels out. P minus 5 cancels out. Now what do you have left? I have 3p on the top, 6 minus p on the bottom. Now, can you cancel the p's? Can you reduce the 3 and the 6? No, because 6 is not a factor, it's a term. P is not a factor, it's a term. Now these are both factors, but these are not, so they can't cancel. So that's your final answer. Okay, this is problem number 5, and we've gone to division now. These two fractions are divided. Well, how do you divide fractions? You keep, change, flip, or multiply by the reciprocal. So your first step would be just to recopy the first part of the problem just as it is, and then flip. So now our numerator becomes the denominator, and our denominator becomes our new numerator. Now we have to factor all 4 of these polynomials. So let's get started. Alright, our first one, 2s squared plus 9s plus 4. There is no greatest common factor. I do have a coefficient in front of my first term, so I'm going to use the AC method. So 2 times 4 is 8. I want a pair of numbers that multiply to give me 8, but add up to give me 9. Obviously that's 1 and 8. Now we're going to rewrite the trinomial, splitting that middle term into 1s plus 8s from here. Now we have a 4-term polynomial. So these two group together. Greatest common factor here is s, so I'm going to have 2s plus 1. Greatest common factor here is 4, so I'm going to have 2s plus 1. These two match, so that becomes my first set of parentheses. My second set is made up of those leftover coefficients in front. So over here I've got 2s plus 1, s plus 4. Okay. Now let's move to the next numerator. Now I'm going to factor 2s to the second minus 3s plus 1. Once again, no greatest common factor, trinomial, coefficient in front of the quadratic term, so that tells me AC method. 2 times 1 is 2. Now, what numbers will multiply to give me 2 but add up to give me negative 3? Well, they're both going to have to be negative. Alright, we're going to rewrite this as 2s minus s minus 2s plus 1. Then we're going to group and take out greatest common factors. Greatest common factor here is s, so that's going to be 2s minus 1. Greatest common factor here is just negative 1. Now when I take that negative out, it's going to change this sign, so I've got 2s minus 1. Now these are common, so I have 2s minus 1 times s minus 1. Okay, let's work on denominators. Now right here, this is a difference of 2 squares, and there is no greatest common factor. So I'm just going to go ahead and factor that into 1 plus 2s, 1 minus 2s, and then we need to factor this last denominator. Alright, so I have 2s to the second minus s minus 1. No greatest common factor, trinomial, coefficient in front of the first term, tells me AC method. 2 times negative 1 is negative 2. So I'm going to have negative 1 positive 2, positive 1 negative 2. I want the pair that will add up to give me negative s. So that's going to be this one. So I have 2s to the second plus 1s minus 2s minus 1. I'm going to factor by grouping. And greatest common factor here is s. So I have 2s plus 1. Alright, my greatest common factor here is just going to be a 1. So when I factor that out, I've got 2s plus 1. Now that these two things match, I have s minus 1 and 2s plus 1. So let me come over here, s minus 1, 2s plus 1. And let's erase this so we can see what we have over here. Alright, let me get a different color so we can see what we're marking off here. The s minus 1's right here cancel. 2s plus 1's cancel. Let's see. This would cancel with that, wouldn't it? If they were reversed. So this is that thing that catches your eye. When you have that, the same numbers, they're in the opposite places and they have a minus sign in there. What do you do there? You're going to multiply by negative 1 over negative 1. Okay? So let's come out here. Now you're going to use one of them. It doesn't matter which one. I like to use the bottom one. So if I multiply negative 1 times this, that changes it to 2s minus 1. And then I can cancel there. Okay? So what do we have left over? Well, we have that negative 1. And we have this s plus 4. Then down here I have 1 plus 2s. So, and nothing else will cancel. We've used up everything, so you're good to go on that one. And example number 6. So once again, we do have a division problem. So the first step is just to keep, change, flip, or multiply by the reciprocal. First thing doesn't change, sign changes to multiplication, and second fraction is flipped. Now we're going to go through here and factor all of these. Luckily, most of these are binomials, so it shouldn't be too difficult. This does not have a greatest common factor. It is a difference of 2 squares. When you factor k to the 4th minus 16 as a difference of 2 squares, you get k squared plus 4, k squared minus 4. Now, this is still a difference of 2 squares. So, we're not going to do anything to this but carry it along. We don't want to lose it. This will factor into k plus 2, k minus 2. So, the first thing on our final bar over here is going to be k squared plus 4 times k plus 2, k minus 2. Alright, now let's factor this next numerator. 12k squared plus 18k. It's not a difference of 2 squares. Greatest common factor, first of all. That will factor into 6k. Alright, what would you multiply 6k by to get 2k squared back? 2k. And it's a plus. And then 6k times 3. So this is just going to be 6k times 2k plus 3. Alright, now we do have one trinomial, and it does not have a greatest common factor. It does have a coefficient in front of the first term. So let's come over here, 2k squared minus k minus 6. AC method, multiply a times c, you're going to get negative 12. Now we need a pair of numbers that will multiply to give us negative 12, but add up to give us the coefficient of this, which is understood to be 1, and it's negative. So you've got negative 1 positive 12, positive 1 negative 12, negative 2 6, 2 negative 6, negative 3 4, 3 negative 4. Now I'm looking for negative 1, so it's going to be that one. So I'm going to rewrite this trinomial into a polynomial with 4 terms. My first term will not change. My second term is going to be broken up into whatever I got down here. And my last term won't change. Now that I have 4 terms, I'm going to factor by grouping. Greatest common factor, k. So I have 2k plus 3. Greatest common factor here, and this is minus, so it's going to be 2. When you factor it out, this becomes a plus. Now that these match, your new factors are k minus 2, made up of these 2 numbers, and your other factor is 2k plus 3. So let's come down here, and that's going to be k minus 2 and 2k plus 3. Alright, last thing to factor here. It is a binomial. Greatest common factor is going to be 4k. Let me see if I can just do it on the fly here. When I factor 4k out of this, what do I have left? K squared. And when I factor 4 out of this, what do I have? 4. Alright. So let's see what all will cancel here. And this is the sum of 2 squares, which we don't have a formula for. So fortunately, it's going to cancel with that one. Alright. K minus 2 here cancels with that. 2k plus 3 cancels with that. So what all do I have left here? That got kind of messy. So what I have left on the top is that 6k and k plus 2 over this 4k. So you see, these are factors now. You can cancel. The k's cancel out. 6 over 4 will reduce down to 3 and 2. Both of them will divide by 2. So your final answer over here is going to be 3 times k plus 2 over 2. And remember, you're not going to start distributing because you spent all this time factoring. So don't undo all your hard work. Final answer right there. In the next section, we're going to look at how to add rational exponents. So before we do that, let's just briefly review how you add fractions anyway, because it's different from multiplication. In multiplication and division, you do not have to have a common denominator. For addition, subtraction, you do. So what you used to do, like if you wanted to add 1/2 plus 1/3, you had to change those to two fractions that had the same denominator, and you wanted to pick for the denominator your least common multiple. So that's the lowest number that both of these will go into. Now this one's easy to spot. You knew that was 6. So you ask yourself, what did you do to 2 to get to 6? Well, you multiplied it times 3. So you got to multiply the top times 3. And this time you multiplied 3 times 2 to get 6. So you got to multiply the top times 2. So you got 5/6. All right. Now, what about this one? 1 over 6 plus 1 over 10. You're not necessarily going to have to multiply 6 times 10 because that's too big. You want the lowest number that both of these will go into. So the process for that was actually to prime factor each one. This would factor into 2 times 3, and this would factor into 2 times 5. Now for each denominator, you're going to pick one of every common factor. So when we look through here, we have 2's and we have 3's and we have 5's. Then you want to pick the highest exponent of anything that you have. Now for this example, I don't have any exponents, but just for future reference, you are going to pick the highest exponent if you have an exponent. So what is 2 times 3 times 5? Well, that would be 30. So you see there is a number smaller than 60 that both of these will go into. And then you'd ask yourself, what did I multiply 6 by to get 30? 5 times 1 is 5. What did you multiply 10 by to get 30? 3 times 1 was 3. So you got 8/30ths. If you'd have gone with 60, then you have to reduce it down, which isn't a big deal in this kind of a fraction, but when we're dealing with rational expressions, we want the least common multiple. So let's get a real rational expression and look at it. All right, let's look at example 7, 3 over 4w minus 2 over 5w. What is the smallest number that both of these will go into? So let's prime factor both. Now 4 prime factors into 2 squared w, and this prime factors into 5 times w. So take one of everything and the highest exponent of each one. So you've got a 2 squared, you've got a w, and you've got a 5. Now you don't need another w. You've already got the base. You just want to take the highest exponent. So multiply this real quick. 2 squared is 4 times 5. So your common denominator is going to be 20w. Now, don't forget to adjust your numerators though. So you have to ask yourself, what did you multiply 4w by to get 20w? You multiplied it by 5, so you have to multiply the numerator by 5. So that gives you 15. Now what did you multiply this denominator by to get 20w? That one was multiplied by 4, so you got to multiply this by 4, so you get 8. So your final answer is 7 over 20w. Now, if it needs to be factored and reduced, you would do that at this point. All right, let's look at problem number 8. 2x minus 1 over x plus 4 minus 3. What do you do when you have that whole number? Well, you need common denominators, but you don't even have a fraction, so put the whole number over 1. Now, you look at your two factors here, your two denominators. You want one of everything, and you multiply them together. So that's going to give you x plus 4 on both of them. Okay? Now, you ask yourself, what'd you do to the old one to get the new one? Nothing. So your numerator is not going to change. And you say, what'd you multiply this by to get your new one? So you're going to multiply this times x plus 4 and get 3x plus 12. Okay, now when you have two fractions that have the same denominator, you can combine those over one denominator and then just have your numerator. Now we also, in this step, let's go ahead and get rid of the parentheses by distributing. There's a positive 1 out here, so that is not going to change. Now what is going to change is when I have to distribute that minus sign. So that's going to be minus 3x minus 12. Okay. Now let's combine and simplify. 2x minus 3x gives you negative 1x, or just negative x. Minus 1 minus 12 gives you minus 13 over x plus 4. And that's going to be your final answer. Remember, you can't cancel out x's because these are terms. They're not factors. All right. So that is your final answer on that one. Okay, here's example number 9. We have fractions. Let's follow the method. And the method is to factor your denominators and then take one of each factor and the highest power of each. That's just something you memorize. When you need to combine fractions, factor and take the highest power of each one. All right, this factors into r plus 5, r minus 5. And this won't factor. It's just as low as it can be. So what is our new denominator going to look like? Well, it's going to have one of everything. So if I take everything in this one, I've got r plus 5, r minus 5. Now over here, I've already got an r minus 5, so I don't need another one. All right, my denominators are going to be the same for both. That was the point. Okay, now let's adjust numerators. What did I multiply this old denominator by to get the new one? Nothing. 1. So my numerator is not going to change up here. Now, what did I multiply this old denominator by to get the new one? I multiplied it by r plus 5. So you have to multiply the top by r plus 5. And I can go ahead and distribute. Since this is a plus sign, it's not going to change any of the signs. So I have 6r plus 30. And remember, since denominators match, now we can combine and just use one denominator. All right, when I add here, r plus 6r is going to be 7r, and 5 plus 30 is going to be 35. Now, if you can factor your numerator, you need to do that because it might cancel out with something. So is there a common factor between 7r and 35? Yes. 7 goes into both of them. So I'm going to divide that out. And now that gives me r plus 5 over r plus 5 times r minus 5. So you see, now these two things cancel out and your simplified answer is 7 over r minus 5. Okay, here's number 10. We see rational expressions that are subtracted. So we need a common denominator. And this time, let's just go ahead and write one denominator. Okay, to find a common denominator, you factor first. Factor the denominators you have. This is the difference of two squares. So it will factor into a plus 2, a minus 2. This is a plus 2. It won't factor anymore, so we're good. All right. Now for your common denominator, you're going to take one of every factor you have. So start off, just take everything in the first one, and then we can add to it. A minus 2. Now, look at the next one. Is there anything in this denominator that I don't already have? No. So I don't need anything extra. Go back. If you have any exponents on any of these factors, you're going to pick the highest exponent. So now, look at your old denominator. What was done between here and here? Nothing changed. So your numerator is also not going to change. Now, notice we got that minus sign here, so let's be careful. What changed between here and here? Well, we have an extra a minus 2, and we're going to multiply this 1 times a minus 2. So, what happens when you multiply 1 times a minus 2? Nothing. You get a minus 2. We just have to distribute that minus. So 5a plus 6 minus a plus 2 over a plus 2 a minus 2. All right, let's simplify this. 5a minus a is 4a. 6 plus 2 is 8 over a plus 2, a minus 2. All right, now the numerator, you've got to factor to see if it will reduce. The greatest common factor here is 4. So when I divide that out, I get a plus 2. My numerator was a plus 2 over a minus 2. So these two cancel out. So you've got 4 over a minus 2. And remember, 2 is not a factor, so it cannot reduce with the 4. So this will be your final answer. Okay, number 11, rational expressions. We need to combine these two fractions. Follow the process. The process is to first get a common denominator by factoring the denominators that you have. So this one is already factored. Won't go anymore. This is a trinomial. Now you've got to refer back to your factoring. There is no coefficient in front of your quadratic term, so it's just going to factor into 2 sets of parentheses. Since this is a plus sign, your signs are going to be the same, and they're going to be whatever this is. Q will factor, you want your square root of that. All right, now I need a pair of numbers that will multiply to give you 12, but add up to give you 7. So we're looking at 3 and 4. Okay, now our common denominator is going to contain one of each factor and the highest powers of each one. So I start off with Q minus 4 here. Now look at this one. What does this one have that I don't already have? Well, I don't have a Q minus 3, so I'm going to use that as well. All right, that's everything. That's the highest powers of everything. So now let's adjust our numerators. What did you multiply your old denominator by to get the new one? You multiply it by Q minus 3. So you're going to have to multiply this times Q minus 3. This is binomial times binomial, so we're going to FOIL it, or distribute, however you want to call it. Q times Q is Q to the second. Q times minus 3 is minus 3Q. And 1 times Q is just positive Q. And 1 times minus 3 is minus 3. Now that was the first part. And I'm doing that because this is subtracted. So everything for this numerator has to be adjusted for that minus sign. All right. What did you do to this old denominator to get the new one? You didn't do anything. So we're not going to do anything to this. We're just going to bring it over like it is. Now, we've got to simplify that numerator. So let's come under here. First of all, just within here, what is minus 3Q plus Q? That gives you minus 2Q, right? So we have Q to the second power minus 2Q minus 3. All right, now here I've got to distribute that minus sign. So now I have minus Q plus 1, and my denominator has not changed. I'm just carrying it along. All right, we can still simplify here. Minus 2 minus Q gives you a minus 3. So under here I'm going to have Q squared minus 3Q. All right, minus 3 plus 1 gives you minus 2 over Q minus 4, Q minus 3. Okay, I need to see if this numerator will factor because it might cancel out something with one of these denominator factors. All right, if it will factor, I'll be able to find a pair of numbers that will multiply to give me negative 2, negative 1, 2, 1, negative 2, and add up to give me negative 3. Well, neither one of these adds up to give me negative 3. Negative 1 plus 2 is 1, and 1 plus negative 2 is negative 1. So this is prime. It will not factor. So this is your final answer on that one. Okay, let's tackle number 12. Now we have these two fractions subtracted, and we need common denominators. Now there's nothing to factor here. They're already in factored form. So let's come over here for our new fraction. We're going to take one of each factor. So we have x plus 6 and x minus 1. All right, that's all there is. There's no powers, so we're good to go. Now you ask yourself, what did you multiply this by to get your new denominator? Well, it's multiplied by x minus 1. So we're going to multiply here by x minus 1. Now if you want to, you can go ahead and distribute at this point. Save yourself a step. It's going to be 3x minus 3. All right, let's look at this denominator. What did you multiply this by to get your new one? Well, you multiplied it by x plus 6. And once again, we can go ahead and distribute right here. And if you want to save an extra step, go ahead and distribute negative 2. Okay, so that's going to give you negative 2x or minus 2x and minus 12. All right, simplify. 3x minus 2x is just x. And minus 3 minus 12 is minus 15. All right, down here on the bottom, you've got x plus 6, x minus 1. And nothing else will factor, nothing will cancel, so you're good to go. Simplest form solved. On the last 3 problems, we're going to be looking at complex fractions. All a complex fraction is a fraction on top of a fraction. And it's not any harder, it's just longer. You're going to be doing the same things that you've been doing, you're just going to do more of it. The way we're going to solve these is we're going to solve the top, or simplify. We're going to simplify the bottom, and then we're going to keep, change, flip, and simplify again. So you're building mathematical stamina. Your problems are getting longer, but you're going to have fewer of them. So let's look at our top numerator here. And let's look at the denominators of the numerator. What's going to be my common denominator between 10 and 40? What's the smallest number that both of these will go into? Well, 40 r squared, because this is the largest thing and it has to go into it. Now 10 will go into that. So now you ask yourself, what did you multiply 10 by to get this new thing? Well, you multiplied it by 4r squared. So you have to multiply your top by 4r squared, which is just a 1. All right, now, what did you multiply this old denominator by to get the new one? You didn't multiply by anything, or 1. So that's going to stay the same. All right, now let's come here to the denominator. The denominator of the denominator. So we're going to need 1 of everything. So that's going to be a 3 and a 2r. All right, what did you multiply the old denominator by to get the new one? By 2r. And you multiply that times 1, you get 2r. All right, what did you multiply this by to get the new one? You multiplied it by 3. So you're going to multiply that by 3. All right, now let's do keep, change, flip. The top is not going to change for this step. It's just going to stay. I'm going to change division to multiplication, and then I'm going to flip this. Now I can go ahead and multiply 3 times 2r together and get 6r. 2r minus 3 is going to go on the bottom. Okay. Now all these things are multiplied. So how do you simplify that? First you have to factor anything you can. So look at this. This is a difference of 2 squares. So I can factor that as 2r plus 3, 2r minus 3, and then I've got that 6r. Down here on the bottom, nothing will factor. It's just going to stay like it is. Okay. Your 2r minus 3's cancel out. Now, what about the 6 and the 40? All right, what will go into both of those? 2 will. So this would reduce to 3 up here and 20 down here. The r to the first and the r second, you subtract exponents and put your answer where your largest exponent was. So you got 20r. So now to clean that up, you could come down here and do 3 times 2r plus 3 over 20r. Nothing will reduce. There's no need to distribute because, like I keep saying, when you go to all the trouble to factor things down, there's no need to multiply it back together. Okay, we're at number 14. We only got 2 more to go, so let's hang in there. Once again, complex fractions. So we're going to combine everything on the top, combine everything on the bottom, and then keep, change, flip, and simplify. So let's just focus on the top. I need a common denominator. So what is the common factor or the least common multiple between 6 and 2? Well, 6 is. Both of these numbers will go into 6. So now you ask yourself, what did you multiply 2 by to get 6? Times 3. So you multiply that times 3 to get 3y to the third. All right, what did you multiply 6 by here? By 1. So multiply by 1, nothing changes. Okay? Now down here on the denominator, we have a whole number plus a fraction. So remember, in that case, you put your whole number over 1. Now your common denominator between the two is just going to be the 3y. And you ask yourself, what did you multiply this by to get the new one? 3y. So you got to multiply the top by 3y. What did you multiply this by to get your new one? By 1 or nothing. So that's going to stay 1. All right. Now we are going to keep, change, flip. We're going to keep this just like it was. 3y to the third plus y squared over 6. We're going to change division to multiplication. And then we're going to flip this. So we're going to put 3y on the top. And we're going to put 3y plus 1 here on the bottom. Okay? Now we have everything multiplied together. So we need to factor if possible. Let's come down here. Now, is there a common factor between this? Yes, there is. Y squared will go into both of those terms. So when I factor that out, I get 3y plus 1. And that is multiplied by the 3y. See, all of these are factors now. All right, down here, 6 is fine. And 3y plus 1 is a binomial. It is not a difference of two squares. It is not a sum or difference of cubes, so it will not factor. Process of elimination on that. You have to know what options you have so you can know if any of them fit. All right? This reduces with this. 3 will go into 6 and leave 2 left over. So what do we have? Y squared times y gives you y to the third over 2. And that is the final answer. All right, this is number 15, our last complex fraction and our last example for lesson 3. So let's knock it out. All right, we need to do the top first. So what is a common denominator between 5 and 10, n and m squared? We need one of everything. So 5 will go into 10, so we only need the 10. And then we have m squared n. I like to put my letters in alphabetical order. All right, now let's adjust numerators. What do you multiply 5n times to get 10m squared n? Well, 2m squared. So we're going to multiply this times 2m squared, and that's going to give us 8m to the third. All right, what did you multiply this denominator by to get the new one? Well, times n. So you're going to multiply this times n. Here's your plus sign. So you've got n to the third up there. Okay, now let's do the bottom. What is a common denominator between n squared and 2mn? Remember, you take one of everything and the highest power of each one. So I've got 2mn, that's one of everything. What's the highest power of one of those that you have? N squared. Okay. Now, what did you multiply this by to get the new one? 2m. So you multiply the top times 2m, so that gives you 2m. What did you multiply this by to get the new one? Well, the only difference is this has just an n and this has an n squared. So you multiplied it by n, so you're going to multiply this by n. Okay? Now, all we're going to do here is keep, change, flip. We are going to keep this just like it is. We're going to change division to multiplication, and we're going to flip this. So we're going to put 2m n squared on top, and the 2m plus n on the bottom. All right, since these are multiplied, all these things are factors. Now, we need to factor each factor if possible. This first one is a sum of cubes, and we know how to factor that. So we are going to need the cube root of that. Since this is plus, we're using SOAP, it's the same. So that's going to be plus n. Alright, now we need this squared, so that's 4m to the second. The opposite sign, so that's going to be minus. The middle term we multiply together. I'm just using the formula, okay, 2mn, and then the last sign is always positive, and it is this number squared. Alright, now let's see what else we have. That took care of this. So we have this 2m n to the second all over 10 m squared n times 2m plus n. So let's see what will cancel. This goes with that. Nothing matches that, so it's going to have to stay like it is. Alright, how about this with this? Well, 10 and 2 will cancel and leave me 5. The m and the m squared will cancel and just leave me m here. And then the n's cancel, but since the highest exponent is up here, that's going to stay up there. So my final answer on this problem is this trinomial right here, the 4m squared minus 2mn plus n squared times that little n down there. Now what do I have for my denominator? 5m. Final answer. Good job, y'all. Work hard on those homework problems.